Long before compost tea buckets and bottled microbial blends, farmers in the Himalayan foothills relied on a ferment so effective it sustained crops on thin mountain soils year after year. These were not experimental practices. They were survival systems, developed where land was scarce, seasons were short, and failure meant hunger. What they created quietly outperforms most modern compost teas because it was designed for resilience, not convenience. This guide explains what the Himalayan ferment is, how it works at a biological level, why it consistently delivers stronger results than compost tea, and how it can be applied today without abandoning modern gardening entirely. How Himalayan farmers discovered fermentation as soil medicine. In high-altitude regions of Nepal, Bhutan, northern India and Tibet, organic matter was limited. Crop residues were precious. Animal manure was scarce and often reserved for fuel. Farmers observed that when plant matter was fermented before application, fields responded faster and remained productive longer. They were not chasing nutrients alone. Fermentation allowed them to concentrate biological activity into small volumes, making every application count. What makes the Himalayan ferment fundamentally different from compost tea? Compost tea is primarily aerobic and short-lived. It extracts microbes from compost, but, often struggles to maintain diversity and stability. The Himalayan ferment is anaerobic and slow, designed to preserve and multiply resilient microbial communities that thrive under stress. This ferment is actually much closer to a microbial preservation system than just a nutrient wash. It really feeds the soil biology first, and the plants come second. Let me tell you how the ferment was traditionally made up in the mountain conditions. Farmers would gather hardy local plants, often those quick-growing weeds, leftover crop residues, or even medicinal herbs that were known to do well in poor soil. They'd chop everything up nice and fine, then pack it all tightly into clay jars or wooden vessels. Sometimes just a bit of salt or mineral-rich ash would be added, not to kill off the microbes, but simply to help guide the fermentation along. Water was only added in just enough quantity to submerge the plant material, no more than that. The vessel would then be sealed up and left in cool conditions for weeks, sometimes even months. It's really time, not agitation, that does all the work here. Now, let's talk about why slow anaerobic fermentation creates, superior soil inputs. During this process, complex plant compounds actually break down into simpler forms, while beneficial microbes multiply. These microbes, you see, are adapted to low oxygen, fluctuating temperatures, and limited nutrients, the very same conditions you often find in depleted soil. When these microbes are introduced to garden beds, they establish themselves quite quickly and outcompete harmful organisms. That's really why the results appear fast, but, they remain stable over the long run. Here's how this particular ferment corrects soil problems that, compost tea simply cannot. Compost tea often gives a temporary microbial boost, but that tends to fade away rather quickly. The Himalayan ferment, on the other hand, integrates right into the soil structure, improving nutrient cycling, water retention, and even root signaling. Gardeners using this method, often report improved plant colour, stronger stems, and, deeper root systems within just a single growing cycle. It doesn't shock the soil, not at all. Instead, it conditions it. Now, here's how modern growers can prepare a simplified version, step by step. First, select hardy green plant material from your local area, especially those weeds that honestly grow aggressively without much care. Chop them up finely to increase the surface area. Then, pack them tightly into a non-metal container. After that, add clean water until the material is just covered. Seal the container and store it in a cool, shaded place for at least 3 weeks. If you let it ferment longer, you'll find the potency increases. Once it's ready, dilute the resulting liquid heavily before you use it. And, very importantly, apply it directly to the soil, not the leaves. Now, you see, dilution actually matters a great deal more than sheer strength. Ancient farmers, they understood well that concentration without proper balance could, really harm the soil life. The ferment was always, and I mean always, diluted to avoid overwhelming the microbial communities that were already present in the soil. So think of it more as inoculation, not just fertilization. Here's how this method fits into modern gardening. And, it certainly doesn't mean you have to abandon compost, mulch, or any other organic practices. In fact, it actually enhances them. When applied from time to time, this ferment speeds up decomposition, improves nutrient availability, and, really strengthens the soil's resilience against both drought and disease. It's especially effective in tired soils that no longer respond to compost tea. So, why did Himalayan farmers trust this method across generations? Fields treated with fermented inputs remained productive, even when inputs were reduced. This kind of reliability really mattered in mountain environments where resources could be a bit unpredictable. The ferment became part of a closed-loop system that, quite wisely, prioritized soil longevity over immediate yield. It's kind of interesting. Modern science is only now catching up. Research into anaerobic soil microbes, plant microbe signaling, and fermented organic inputs, it all confirms what these farmers already knew. Stability, it turns out, matters more than stimulation. And honestly, diversity matters more than volume. Now, why does this method matter for the future of sustainable growing? As soils degrade and inputs become expensive, methods that regenerate biology rather than simply replace it become more and more important. This ferment, you see, requires no machinery, no electricity, and no proprietary ingredients. It works because, it respects soil as a living system. Why, you might ask, should serious growers reconsider fermentation as a core practice? This is not folklore or novelty, not at all. It is applied microbial ecology, refined under extreme conditions. It survives because, quite simply, it works. If you value agricultural methods that have, fed communities for centuries under pressure, do subscribe to the Husbandry channel and share this guide. Knowledge like this does not belong in archives. It belongs back in the soil.